Time, a never-ending one-direction flow of events, where the past and the present are believed to be locked, while the future is fluid and dominated by uncertainty. Albert Einstein observed that time isn't a constant, but instead is fluid, being increased arbitrarily by gravity and propulsion. Ever since, forward time travel has been constantly observed to be a common phenomenon in the universe. His equations show that through time dilation, the faster one travels at a proportion of the speed of light to near light speed, the slower time flows. Because the speed of light doesn't budge, time is budging instead, and at such high velocities, besides time, the perception of distance is also changing, transforming the way we see space. The faster an object is traveling, the shorter the distance perceived, as compared to the actual distance. For example, if you were a photon, because you have no mass and travel at the speed of light from the moment of your inception, from stars, quasars, and other objects until the moment you reach a surface over billions of light years away, or a surface very close from where you were born, you would basically experience no time. Your experience will be of simply being born and instantly crashing, regardless of the distance traveled, only being able to perceive time as you slow down right before hitting the surface. The faster you travel, the more time is slowing down. And also, because time is bound to space in a plane aptly called spacetime, gravity, due to its nature, curbs the fabric of this spacetime, interacting with the gravitational fields of massive objects, such as black holes and neutron stars, dilates the time of the objects that are near them. Objects with mass can never reach the speed of light, but if a mass object could ever reach a speed of 99.999% the speed of light, then you would be able to travel billions of light years in a second. While for you, as you travel those billions of light years, just a second has passed, for the people on Earth, as you complete your journey, billions of years will have passed. Basically, that's what the experience of light speed travel is. Nevertheless, this time dilation only becomes apparent when you surpass 75% the speed of light. So no need to worry if you drive very fast with your car, besides getting a ticket, or take an airplane. In the future, this type of forward time travel is the most probable way that we will be able to travel through time, because our current understanding of physics permit it. It only remains a matter of developing the technology to travel at near light speed velocities. Currently, we can produce machines that can reach 10% the speed of light, so there is still a long way to go. But if you were able to produce a spacecraft that can travel at 99.999% the speed of light, and you would like to see how Earth would be in say 14,000 years, you would merely have to get in the spacecraft and travel in any direction for 7,000 light years and return. And while for you only about 2 months would have passed, on Earth 14,000 years have gone by. So this is one of two ways of forward time travel that we know of. The other way involves gravity, as time is being dilated when interacting with the immense gravity fields of massive objects such as neutron stars and black holes. Because time is linked to space as one field, aptly named spacetime, objects through their gravity bend this spacetime. And if you were able to travel near such an object, like a black hole, and bathe in its gravitational field, because black holes are literally holes in the fabric of spacetime, time is literally dilated along with space in a curvature/pit/hole type of structure until it reaches the singularity, and then time stops altogether. Basically, in the singularity, like the photon, you experience no time. But if you are able to avoid getting sucked into the black hole and not get past the event horizon, past the point of no return, because space-time is so curved around it, when you travel near it, from point A to point B in a straight line, it wouldn't be a straight line anymore, but an arc. Basically, the same distance will be much longer than in normal space, thus more time would have passed. Studying black holes, gravity, and gravitational waves will hopefully allow us someday to manage and manipulate gravity, and as such time itself, possibly creating a stationary forward time machine that will use gravity to move time forward. So all of this so far was only regarding forward time travel. But what about backwards time travel? What does the physics say about that? Unfortunately, regarding backwards time travel, there is little to no progress so far. The main reason for this is because traveling back in time breaks the principle of causality. Nevertheless, the only viable mathematical way to do such a thing is by using a timeline curve, a giant space tunnel that links two contrasting points in spacetime. A wormhole, a theoretical structure that connects two different points in space, disregarding traditional distance, with the most plausible candidates so far being black holes, with their singularity that might be able to rip open a point in the fabric of space. So, the idea is that if two black holes connect to a wormhole, they could theoretically retain their different separate points of time. We then use the time dilation phenomena of black holes to move one entrance of the wormhole into the future that will be used to travel to the side that has not been moved to the future. Basically, we will create a backwards time machine to the present moment. This sort of structure will permit us to go at any place in the future and return back to the present. And while the math on this one is very strong, a major drawback is that it requires a lot of exotic matter that has a negative energy value which violates energy conditions. Nevertheless, some quantum physics effects can lead to small violations that make possible the accumulation of a very tiny amount of this type of stuff, but not nearly enough for the industrial quantities needed to create such a structure. Besides this, wormholes by themselves remain only a theoretical concept, with no evidence so far that they exist. But if at some point in the future this would be possible, then we would be able to use such a device to see our future. And because the future is thought to be fluid, we could theoretically go to our future and look at our past from that point of view, and observe possible mistakes our society may have made, returning after and trying to prevent them, one of many possible uses for such a device. Nevertheless, this is still not a proper backwards time machine, not allowing us to go from the present to the past. And unfortunately, this is as far as the mathematics take us regarding backwards time travel. From here on, things get less scientifically and more philosophical and conspiracy theory-ish, with the main dilemma being the grandfather paradox, which breaks the principle of causality that seems to dominate the universe. Disrupting the cause of a current effect will probably alter current reality in unimaginable ways. With many pop culture references in movies and TV shows, the grandfather paradox states that if a person travels back in time and then kills their grandfather, then the old timer won't be able to produce offsprings, which will erase the time traveler from existence. But if the traveler is no longer born, then the grandfather isn't murdered. All of this leading to a loop. But a counter-argument to this states that if a time traveler disrupts a cause in the past, then the past will branch out into a new reality, creating a separate universe that will live out the new experiences of the new choices and will isolate the traveler in the process. But at this point, there is no tangible mathematical solution to the idea of traveling in the past, with most theories being just speculations. Some say that time doesn't exist altogether, reality being made up just from the cycles of events that happen in nature, such as the formation of planets, rotations of electrons, molecules vibrating, and the sun rising and setting, with the idea that time is just an invention of humanity to cope with its mortality, being able to describe perfectly well the universe without the use of time. Nevertheless, time is a useful tool for us, making day-to-day life easier and helping humanity to better understand and more easily define the events that happen in the cosmos. All in all, more research needs to be done regarding these concepts, at some point proving beneficial and maybe will eventually improve the quality of life on the planet. Okay. Thank you all for watching the video. I hope you enjoyed it, and until next time, take care.